The Gateway project is a revolutionary step worth $16 billion, which aims to reconstruct these century-old corrosive railway tracks that link New Jersey with New York City. It aims to refurbish existing tunnels and expand rail line speed and overall capacity through modern, innovative construction techniques, which will increase sustainability and connectivity within the urban landscape. In late October 2012, when Hurricane Sandy rampaged through the United States, it severely damaged the already aging infrastructure of the Northeast Railway Corridor, or NEC, which is the busiest railway corridor in the USA. As a result of this natural disaster, the government proposed a plan to upgrade the infrastructure of the railway system, and today we'll be looking at this project's needs and urgency, ambition and advancements, along with the challenges. Back in 2012, Hurricane Sandy had a drastic impact on the lifespan of the current infrastructure in the northeast region of the United States, particularly in the New York City metropolitan area. The storm caused extensive damage to critical transportation frameworks, including railways, tunnels, bridges, and roads, specifically the century-old tunnels that connect New Jersey and New York City beneath the Hudson River. The storm surge flooded these tunnels with salt water, causing corrosion and damage to electrical systems, tracks, walls, signals, and other structural components, which significantly reduced the lifespan and operational reliability of the railway system. In addition to the tunnels, Hurricane Sandy also impacted other critical transportation paths, which include bridges, stations, and roadways. The storm's high winds, heavy rainfall, and storm surge created structural damage and flooding, which led to prolonged service disruptions and transportation delays. This disturbing aftermath of Hurricane Sandy served as a wake-up call for policymakers, transportation agencies, and infrastructure planners to come up with adaptive strategies and mitigate the impacts of future extreme weather events. An interesting point to note is that the Gateway program is more revolutionary than just protection from external threats, as the project aims to regulate the growing need for economic fluidity. The increasing population has an increasing requirement for basic, smooth transportation, and the existing system is inadequate to satiate that need. The current two-way train pathway between the New York and New Jersey section of the corridor is only capable of operating 24 trains in an hour and sees almost 700,000 passenger trips a day. But with the construction of the Gateway program, these numbers will double up and easily facilitate the locomotion of the ambitious younger generation and pave the way for economic vitality in the region. In the Gateway Tunnel project, numerous bridge constructions and replacements are scheduled, including rail bridges in the New Jersey Meadowlands, modification of the old 20th century tunnels, and building new tunnels underneath Bergen Hill and the Hudson River, along with the expansion of the New York's Penn Station. The replacement of aging bridges with modern counterparts reflects a proactive approach to addressing critical transportation bottlenecks and vulnerabilities. Advanced construction materials and methodologies play a central role in the bridge replacement process. Engineers utilize high-strength, corrosion-resistant materials to enhance the durability and longevity of bridge structures. Furthermore, innovative construction techniques such as precast concrete segments and modular bridge components expedite construction timelines while smartly minimizing disruptions to existing traffic flow. The Gateway program also includes site work such as drainage, grading, and storm water management to avoid corrosion from reoccurring. Moreover, to maximize efficiency and maintain traffic flow, patches of land from roadways and utilities are temporarily relocated and individually revamped one after another to accommodate future tunnel tracks underneath the land. What's even more impressive is the incorporation of new intelligent technologies that will enable real-time monitoring and maintenance of bridge assets, ensuring optimal performance and safety throughout their operational lifespan. These technologies will include sensors, data analytics, and predictive maintenance algorithms, allowing transportation authorities to proactively identify and address potential issues before they escalate into more significant problems. This will not only minimize the effort and overall construction time, but also the required cost to fix the issue. While the idea has been lingering around for almost a decade, the proposal for the Gateway Tunnel project was formally approved in 2021. The tunneling is said to begin in 2025 and will be finalized and operational around the year 2035. If you're wondering why a whole decade will be consumed in the process, that is due to the numerous components that are going to be targeted in this project, including tunneling that requires the use of TBMS, which is a tunnel boring machine that performs the excavation process with its rotating head and makes a hole in the ground by using a motor with a hydraulic or electric system. These machines have surgical precision, which allows them to successfully navigate their way through tricky geological landscapes and conditions. They're semi-automatic because of the advanced laser systems and GPS that help guide the machine through real-time monitoring. Engineers can sense obstructions and hurdles beforehand and are able to make necessary adjustments for smooth tunneling. Other than that, the Gateway program includes the reconstruction of the Portal Bridge, which is a 2-track movable swing-span railroad bridge over the Hackensack River in Kearney and Secaucus, New Jersey. It is the busiest train span in the Western Hemisphere, carrying between 150,000 and 200,000 passengers per day on approximately 450 daily trains, and serves as a vital link for Amtrak and NJ Transit trains traveling along the Northeast Corridor. The primary need for Portal Bridge's reconstruction arises from the fact that there have been frequent malfunctions and other mechanical failures, which has caused significant inconveniences both to the civilians and the government. The new bridge is designed to eliminate the movable span, which will reduce malfunctions and increase reliability. Moreover, the new bridge will feature a higher clearance over the Hackensack River, which will further enhance unimpeded maritime navigation and rapid transport while minimizing disruptions to rail traffic. The Gateway project is not only limited to the Northeast Corridor, it extends over to Manhattan, specifically the Hudson Yards, where tunnel boxes are going to be installed underneath actual buildings. Complex and accurate engineering will ensure that both the tunnels and buildings are strong enough to uphold their structure and not affect the intricate framework of one another. Then, the replacement of the Sawtooth Bridges, which were originally built in 1907 in Kearney, New Jersey, between Newark Penn Station and Secaucus Junction, and include an approximately 1.9-mile-long segment of right-of-way along Amtrak's Northeast Corridor. Because these bridges have a 2-track configuration, they act as frequent choke points in the high-speed route of the Northeast Corridor. As a result, the Gateway program hopes to double its pace by upgrading it to a 4-track configuration model. The Dock Bridge is a 6-track, triple-span movable lift bridge, and although it is wider than the Sawtooth Bridge, it still requires repairing as the structure is nearly 90 years old and has a weak overall stature. Moreover, just like the Portal Bridge, the Dock Bridge rehabilitation will include restricting the movement of the lift bridge for faster and smoother transport. The Gateway program also includes the reconstruction of the Secaucus Junction, and unlike its name, Secaucus Junction is not a true junction. So the program proposed to build the so-called Secaucus Loop or Bergen Loop tracks connecting the main line and the NEC at Secaucus, thus creating a true junction station. This will allow a 1-seat ride to MTA Metro North Riders and NJ Transit and directly link them to Penn Station, New York, without changing transport, making it way easier for travelers to travel back and forth between the two places. Lastly, the Gateway program also aspires to enlarge and expand the Penn Station, primarily in terms of improved rail infrastructure, resistance against extreme weather, and increased capacity, which will enable more trains to operate during peak travel times. This will ultimately minimize delays and enhance amenities and facilities for commuters in the region. But there is one big problem: maneuvering through the jam-packed, intricate structure of New York. Thankfully, the Gateway program has an on-paper solution for it, which includes employing critical strategies such as prefabrication of components off-site, optimizing delivery routes, and staging construction activities strategically will help engineers navigate through densely packed neighborhoods with careful logistical planning and ensure efficient movement of materials, equipment, and personnel while minimizing impacts on surrounding communities. All in all, the Gateway program responds to the Northeast Corridor's need to update and expand its rail system. By rehabilitating tunnels, increasing train capacity, and modernizing roadways with better technology, the program aims to meet the city's evolving transportation demands through various innovative projects, such as undersea rail tunnels and bridge replacements that demonstrate commitment and conviction. Despite the challenges it faces in terms of budget, the Gateway program is without a doubt a significant step towards a more connected and resilient transportation network for the United States of America.